In this example, we are going to find the equation of a tangent line to the curve y equals 3 square root of x at the point x equals 6. And we're going to do this in parts. In part A, we're just going to find the slope, which is the instantaneous rate of change. And then in part B, we're going to find our values for the line M and B. So the first thing we're going to do is use our limit definition. And everywhere I see x, because we're doing this for specifically the point x equals 6, I'm going to plug in 6. So here's 6 here and 6 here into our limit definition for the derivative. Now, I need to find f of 6 plus h, which means everywhere in the function f, I'm going to plug in 6 plus h and substitute that in for x. So that goes in here under the square root. So f of 6 plus h is 3 times the square root of 6 plus h. F of 6 is just 3 times the square root of 6, and then I put that all over h. Now, I have to do some work. So typically, not all the time, but typically when you're dealing with square roots and you can't use direct substitution to find the limit, usually the conjugate trick works. So I'm going to multiply the top and the bottom by this expression of the conjugate of 3 square root of 6 plus h minus 3 square root of 6. So that conjugate would be the same exact thing, but I just changed this minus to a plus. So I'm going to multiply the top and the bottom by 3 times the square root of 6 plus h plus 3 square roots of 6. Now when I do this, this becomes, because I have the same exact expression, but one's plus and one's minus, this is going to give me the difference of squares. So this is going to get squared, which gives me 9 times 6 plus h. This is going to get squared, so that's going to give me minus 54. And then because this is minus and this is plus, the middle term is going to drop out. On the bottom, I'm just going to take this whole big mess and multiply it by h. I'm not going to actually multiply it out to save myself some work, because a lot of times things will cancel. So I'll wait till later to multiply it out if I need to. So now I have 9 times 6 plus h minus 54. I'm going to distribute this 9 here. So that gives me 54 plus 9h minus 54. The 54s drop out, and I'm left with this still in the denominator. And then I'm left with a 9h on top. Now, this h and this h will drop out. H over h is 1. So I'm just left with 9 in the numerator. Because the 54 and this 54 drop out, I'm left with 9h on the top, and then this times h in the denominator. So my h's will cancel. So that leaves me with 9 in the numerator, and my h in the denominator drops out. Now I can use direct substitution without getting 0 in the denominator. When I plug in 0 for h, I get 3 times the square root of 6 plus 3 times the square root of 6 in the denominator, which would give me 6 square roots of 6. So I have 9 over 6 square roots of 6, and that will simplify to 3/2 with the square root of 6 still in the denominator. So what this tells me is that this is the slope of the tangent line at x equals 6 for the function 3 square root of 6. So this is my slope. So looking at part B now, I have my slope, but I still got to figure out what my B is. The point that we're focused on is at x equals 6. So when I plug in to find my corresponding value of y, I get that my corresponding value of y is 3 square roots of 6. So I have this point on my line and on the function. Okay, so this is the point that I'm going to use to plug into my x and y in here for this x and y to solve for b. I have my m, that's this here. I have my 6, that's my x. I have this, which is my y. And then once I plug that in and solve for b, I get that b is 3 square roots of 6 minus 9 divided by the square root of 6. This is the exact value. Of course, you can put it in decimal format, but I think the question wants exact. But you can always check it on your calculator if you want to graph the line with the function and see if it touches just at that one point, x equals 6. But this is the exact answer. So this is your B, this is your M.